Hello dear students, I hope all of you will be fine. So this is assessment problem 3.3, in which we have to find the value of R that will cause 4 ampere of current to flow through the 80 ohm resistor in the circuit shown. So this is basically the circuit in which we have to find out our values. So in this condition we have to find out the value of R such that it is telling us that this 4 amps of current is flowing through this 8 ohm resistor. So as these two are in series, their equivalent resistance will be okay. So this is our input current source, which is of 20 amps. This is 60 ohm. I'm not writing omega here, so if something is written above the resistor, it means it is in ohm. Okay, these two resistors are in series, so their equivalent resistance will be 120, and similarly this is R. So we know this value. This is the 20 amps value, which is the input current. So this is also given that the value here is 4 amps, but the value here, which is IR, is not given. So in order to calculate our required values, let me change the color of my pen. So here we know that in this solution, let me write, it is A. So we know here that according to the KCL, we know that the total current, which is I naught, is equal to the current which is flowing through the 120 ohm resistor plus the value of current which is flowing through this R resistor. So now putting or rearranging it to find the value of IR is equal to I naught minus I 120. Putting values here, we will get IR is equal to I naught is the total current, which is 20 amps, minus the value of I 120, which is given here in our question. So this is now 16 amps. So the value of IR is 16 amps. This is the value which is given here. So after finding it, we can use the current divider law. So according to the current divider law, we know that the value through IR is equal to the value of the resistor, which is at the other end, divided by the 120 plus R multiplied by the total current. So the total current here is 20 amps. Okay, we know all the values except this R here. So putting all the values here, I mean this IR here. So IR is again the value which we have found here. So this is 16. Putting 20, dividing both sides by 20, we will get here 20, and similarly 120 divided by 120 plus R. So after rearranging and calculating the values here, we will find out that the value of R will be equal to the 30 ohm. So this is the value which we needed for the part A of this question. So when we have found it out, what is the second part of this question? This is part B. So how much power will the resistor R from part A will need to dissipate? If we have found out the value of R, so how much power will it dissipate? We know all the formulas for the power dissipation. So to find out the power dissipation here, we know the formula, which is IR square into R. So the value of IR is how much? We have found it out here. This is 16 amps. So 16 whole square multiplied by the value of R, which is 30. So after calculating it, we found that this is 7680 watts. So this is the required result which is asked to find in part B of this question. How much power will the current source generate for the value of R from part A? So how much current, how much power is it basically generating and passing it to the overall circuit? So in order to find out this, we have to find the equivalent circuit here. So because we know this is the source, so to find out the power generated by the source, we will have this formula, P is equal to IV. We know the value of I, but we don't know the value of V. So to find out the value of V across it, we have to find out the equivalent circuit. In this equivalent circuit, here we know that this was our circuit. So in this circuit, we knew that this was okay. So it was our circuit here. This was 60 ohm, this was 120 ohm, and this was 30 ohm, which was found out here. And this is the current source. The value of this current source was 20 amps. So the equivalent resistance here will be equal to the 60 plus 120, which is in parallel with the 30 ohm resistor. So this, after calculating it, we found out the value of R equivalent was 84 ohm. Okay, so this was the value. So when it is found out, we can okay, let me go down. Let me go down here. Okay, okay, so this is R equivalent, and from this R equivalent we can draw a circuit like this one here. Okay, let me rearrange it so that you can easily understand it. Okay, this is our resistor, this is our current source. So this is the R equivalent. So the value of R equivalent is 84 ohm, and the value of this current source was 20 amps. So what will be the voltage here? The voltage here will be equal to V84 will be equal to the 20, which is the series current coming here, and multiplied by the 84. This is almost equal to the it will have some value. So after calculating out this value, we know that, let's suppose this is some value. So after finding out this value, the power dissipation will be equal to IV, putting the value of current here, that is 20 multiplied by again this V84. So 20 multiplied by 20 multiplied by 84, that is, putting this value here, it was put down here. Okay, so 20 square multiplied by 84. So the power delivered by our circuit was 33,600 watts. So okay, this was the result. This was the answer of this question of last part of, in our question. So what did we find out here? This is the overall question. Initially we have started from our circuit. We have found out the value of R, which will assign the value 4 ampere to pass through 80 ohm resistor. Then after it, we find out the power dissipated by this R resistor, which was the 30 ohm, and at the end we have found out the value, the total value of the power, or the total power which was provided by our source. Thank you so much, and I'll see you soon.